Hey guys, this is Mr. Lowry. This is an assignment that we started in class on December 7th, which is a Monday, if you're in Cohort A. If you're in Cohort B, then this will be our assignment for December 8th, which is a Tuesday. So this is our last kind of homework assignment for the semester. And we're just proving some new ideas about triangles here, building on what we already know. And I'm going to help you set up these proofs here and get you going. So this is the angle sum theorem, which is in your book. Sometimes some books might call it the triangle sum theorem, so you might have seen it as the triangle sum theorem in the past. But the idea is the sum of the measures of the angles of a triangle is 180. In other words, the measures of the angle of a triangle all add up to 180 for every triangle. So we want to prove this idea. You might have heard of that idea before, but we actually want to prove it today. So in class today, I helped kind of set this proof up because it's kind of tricky. That's the tricky part. And then I had students work in groups to see how far they could get from there. And we kind of worked it out in pairs. So when we're trying to prove a theorem, the first thing we need to know is like the if and the then. Now this one doesn't have an if-then, but we can kind of force it to. So the sum of the measures of a triangle is 180. So there's kind of like a implied if here, and it's basically if triangle, like if there exists a triangle or if you have a triangle, then the measures add to 180. Or the measures sum to 180. Measures of the angles. Okay. So the if part is basically that we just have a triangle, and that's the part that we assume when we're writing a proof. Okay, so let's start out with a triangle. We're going to make a little figure here to help us out. Okay, and we'll call this triangle, let's say, A, B, C. All right, that's all we can really start with. Or all we can assume so far. What we're trying to show is that this angle plus this angle plus this angle is equal to 180. So given triangle ABC, prove, well, let's hold on just for a second on that one because we're going to add some things to our figure. But basically what we want to prove is the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. All right, now when we're talking about doing a proof, we got to think, what can we add to our figure? Well, if we're talking about triangles, we can have a triangle figure that represents, any old triangle. We can also add some things to this picture if we want to, like parallel lines, for example. So what I'm going to do is I'm going to add basically a construction. I'm going to construct a parallel line. We talked about the things that we can do for proofs. One of the justifications, we can use postulates, we can use theorems, we can use definitions, we can use properties. The other thing we talked about using is a construction. And since we know that for every line and point not on the line, there exists exactly one line that's parallel. So I have this kind of line BC, and I have a point A that's not on BC. That means there's going to be exactly one parallel line through A that's parallel to BC. So that's okay. We can do that. We haven't added any extra information to the assumption. We've just, because any line is going to have another parallel line. So that's fine. We can do that. I'm also going to label these angles here, 1, 2, and 3, just for ease of the proof here. And I'm going to add 2 other points. Again, this is just for labeling purposes, which we're allowed to do on a proof. So we can set up the figure kind of how we want. We're not really adding anything that we're not allowed to add. We're labeling it the way we want. That's fine. So our goal then is to prove that the measure of angle B plus the measure of angle 2 plus the measure of angle C equals 180. So measure of angle B plus measure of angle 2 plus measure of angle C equals 180. For this figure, that would prove then that the angles of the triangle add up to 180. And since we didn't pick specific angle measurements, we're good. All right, let's go ahead and start off our proof here. So step 1 is triangle ABC given. Okay. Now I'm going to give you some hints here, and then I want you to try to work through this. Spend maybe 5 minutes trying to work through this. If you're reviewing, if you were in class today and you just want to practice, this is good practice. But if you're at home working on your own, then this is something you should probably be able to get at least some of the way done. So I'm going to give you some hints here. Okay, first off, I constructed this line so that these two guys are parallel. Okay, so what you have is parallel lines with a transversal here, but you also have a transversal here. So parallel lines and transversals give us congruent corresponding angles, congruent alternate interior angles, congruent alternate exterior, and so on. Okay, so if you think about it for a second, angle B, this guy right here, and angle 1 would have to be congruent since these lines are parallel, because these are alternate interior. Okay, angle 3 and angle C, this guy right here, would have to be congruent as well, because again, those are alternate interior angles. Okay, so we can start off with that kind of idea. Another thing that we can use, and this kind of has to do with the 180 idea, is that 1, 2, and 3 all kind of are angles that form this straight angle. So 1, 2, and 3 have to add up to 180 degrees, but it takes a little bit of a process to prove that. We can use our supplement theorem that, linear pairs are supplementary. However, supplement theorem only works for linear pair, and linear pairs is 2 at a time. So even though I have 1, 2, 3 angles, I'm only going to be able to kind of go a little bit at a time. So let me get you started here and see what you can do. So let's say step 2 is to talk about the alternate interiors. So let's say angle 1 is congruent to angle B, and let's say angle 3 is congruent to angle C. Okay, how do we know that? Because they're alternate interior angles and we have parallel lines and transversals. So we're saying alt int angles theorem. Okay, now let's use that fact. We'll just kind of keep going with that fact as far as we can. Measure of angle 1 equals the measure of angle B, and the measure of angle 3 equals the measure of angle C. All right, that's just the definition of congruence. So now we're going from a congruent statement to an equation, which means we can do some substitutions if we need to. So that is the definition of congruent angles. I'll say def of cong for short. Okay. Another thing that we know is that we have these 3 angles that add up to 180, but like I said, to justify that, it takes some extra steps. So let's talk about 1 and 2 together. If you kind of look at this angle right here, that's 1 and 2 together. We can name that angle XAC. So XAC, this guy, plus angle 3 has to equal 180. That we can justify with the supplement theorem, okay, because that is a linear pair. This full angle plus 3. So we're going to use measure of angle XAC, which is 1 and 2 together, plus measure of angle 3 equals 180. And we're going to go supplement theorem. Okay. And then we're going to do this. This is kind of the hack here. Now, XAC is 1 angle and measure of angle 3 is 1 angle, so we can get away with using a linear pair. But then we'll just break this angle down a little bit further. So measure of angle XAC, this guy, is measure of angle 1 plus measure of angle 2. Okay. So that is going to be the angle addition postulate, right? The sum of the 2 small angles equals the measure of the bigger one. All right, and for step 6 then, we can now substitute, since XAC is 1 and 2, we can now say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Okay? And that's going to be the substitution property of equality. All right, so this plus this plus this equals 180, which is kind of good. We need a 180 in there because this is kind of where we're headed, right? 1 plus 2 plus 3 equals 180. However, we just said before that angle 1 is equal to angle B, or the measure of angle 1 is equal to the measure of angle B, and the measure of angle 3 is equal to the measure of angle C. We already said that up here in step 3. So if we can take this guy and do some substitutions with it, then we'll pretty much get to where we want to go. So see if you can figure that out and finish that up, and pause the video right now and do that. Okay, so coming back from pausing the video, we have a couple more steps here, maybe one or two. So let's just keep I'm going to keep my proof going over here. All right. So right here, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. I'm just going to substitute B for angle 1, and I'm going to substitute C for angle 3. So taking this statement, step 7, I'm just going to say the measure of angle B plus the measure of angle 2, so B plus 2, plus the measure of angle C equals 180. In other words, the angles of this triangle, B, C, and 2, all add up to 180. That's what I was trying to prove, and that's another substitution. Okay, so that's the proof in a nutshell. It uses the idea of these three angles adding up to 180 because of the straight line. But again, supplement theorem doesn't get you there in one step. You have to kind of break it down into a few different steps. Because supplement theorem is all about linear pairs, and three angles is not a pair of angles, it's three angles. You also have the alternate interior idea, and then you do a substitution. Okay, now that proof is in your book on page 185. Okay, so it looks kind of like this. I just wanted to take a quick look at that together so you can kind of see what's going on. They use a lot more steps, and we kind of want to get the basic idea. If we really, really wanted to be rigorous, we could go a little bit further. So they have a very similar setup to what we did, but they said first that 1 and CAY form a linear pair. So they used some different ones. They used this angle 1 and then this angle with 2 and 3. We used XAB and angle 3, but that's the same kind of idea. But they said it was a linear pair first, and then they used the supplement theorem, and then they had them equal to 180. So we did this step 3, 4, and 5. Actually, yeah, 3, 4, and 5 we kind of did in one go. Also, they drew that parallel line. They used the parallel postulate. So it can be a really long proof if you want to get really down into the nitty-gritty details, but we kind of combined step 3, 4, and 5 into one step and just said supplement theorem. And we talked about this parallel line construction. We added that to our figure, and then we got angle addition postulate, substitution. They did alternate interior angles theorem, step 8 and 9, like way farther down the line. We did that right at the beginning, but then they used their substitution the similar way. So this is essentially the same idea as we did. We just did it in a few less steps. So you can kind of look over that as a reference and read through that. If you want to know like a really, really thorough, rigorous, super detailed proof, this is a pretty good one. All right, let's talk about how we're going to use that, okay? So down here in the bottom, we want to apply the angle sum theorem, right? So we just proved it. Now we can use it, and the idea is that for any triangle, the three angle measurements should add up to 180. So in this case, applying that theorem, I would say, okay, well, if that theorem's true, then 3x plus 2x plus 130 equals 180. Okay? When you're doing these problems, I want to see that equation because that equation tells me you understand the relationship. I want to see that, and I want to see your work. Okay? So this is basically what shows me, as I'm grading this, that you understand what this theorem that you just proved is saying. All right, so 5x plus 130 equals 180 when we combine like terms. Now we're just solving a two-step equation. So subtract 130 from both sides. That means 5x equals 50 and x equals 10. Okay, now let's go back and find out what we were looking for. The measure of angle A. Well, this isn't the measure of an angle. This is what x was. So here's angle A. If we want to find out what that is, then we have to take this and plug it back in. So 3 times 10 right? That would be 30 degrees for our final answer. So just like we did last week, we have the step-by-step, problem-solving process. The first step is to read the problem, right? So read the problem and pull out, any information that you might need. Okay, so we look at this and we're like, okay, we got a triangle here. We know the angle sum theorem applies. We're going to set up an equation. We're going to solve it, but then we got to check, do we go back and plug that in or not? So very similar to what we did last week. So you guys take care of these ones. Okay, let's look at one more proof on the back. This one's a little bit shorter. So the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So that's a little wordy. Let's talk about what that means. So we need to draw out a triangle. And for one of the sides of these triangles, we're just going to make it a little bit longer than we need. Okay, so this is the shape that we're kind of looking at. These are the interior angles of a triangle, right? Interior means inside. So we got 1, 2, we got 3 interior angles. Let's call them 1, 2, and 3 for the angles. The exterior angle is one of these guys. If you extended one of the sides of the triangle out a little bit longer, you would form an angle, and that's called an exterior angle. Okay, we already named these angles 1, 2, and 3, but let's name the vertices A, B, and C just so we can name the triangle. So this is the exterior angle, okay? Again, an exterior angle is just if you extend one side of the triangle a little bit longer, that makes an exterior angle. Okay, the interior ones are the inside ones. Now let's talk about the remote interior angles. Okay, remote means far away. So if you think about like remote control literally means you're controlling something remotely, or you're controlling it from a distance. So like the remote control for your TV or something like that, you're controlling your TV while you're sitting on the couch and there's like some distance there. So remote means away from or far away from. So here's 3 interior angles. The remote interior angles are the ones that are farthest away from the exterior. This one's the close one, right? This one's like touching it. This is like the remote one, the ones that are farther away. So what we're trying to prove then is that 1 plus 2 equals 4. Okay, so when you're trying to prove a theorem, remember the if then is the part that you assume. So we have the measure of an exterior angle of triangle equal to the measures of the remote interior. So the kind of implied thing is if we have a triangle. So given, we're going to go triangle ABC. If we have a triangle, then the exterior angle is equal to the sum of the remote interior. So for this figure, we'll put that in like using our figure numbers. So we want to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Now we could label our angles differently. I think when we did it in class we labeled them a little bit differently, but it doesn't really matter. This is the idea that we're trying to prove. Okay, so let's set it up. So statements, reasons. I'm going to start with triangle ABC. It's given. Okay, and we want to prove again that 1 plus 2 equals 4, or the measure of 1 plus the measure of 2 equals the measure of 4. Well, we just barely proved the triangle sum theorem, or the angle sum theorem in the previous page. So you can use that now. We know something about angle 1 and angle 2 and angle 3. Okay, if you look at 3 and 4, we also know something about 3 and 4. So think for a second about what you know about 1, 2, and 3. Think for a second what you know about 3 and 4. See if you can get the rest of the way there on this proof. This is actually a lot easier than the other one. It's only like 4 steps. So pause the video now and try to finish this proof up. Okay, coming back from pause, let's talk about what we know about the angles. So step 2, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180. How do we know that? We just proved it in the previous page. So this is the angle sum theorem. It's also sometimes known as the triangle sum theorem. You could use either there. It's fine. Okay. Let's talk about 3 and 4. What do we know about 3 and 4? Well, the relationship between them here is that they form a linear pair. So, the measure of angle 3 plus the measure of angle 4 equals 180 by the supplement theorem. Okay. Now, again, in your book, they would probably do 3 steps for this one. They would say 3 and 4 form a linear pair, definition of linear pair, therefore 3 and 4 are supplementary, supplement theorem, therefore 3 and 4 add to 180, definition of supplementary. We're kind of combining all of those ideas into one. That's kind of how we've been doing it, just to kind of save us some time. I think we understand that idea that these are a linear pair, they have to add up to 180. And that's we'll kind of include all those ideas in the supplement theorem. All right, notice I have an equation equal to 180 and an equation equal to 180. So if you didn't already, you hopefully know where to go from here. If I have these 3 angles equal to 180 and these 2 angles equal to 180, then I can do a substitution, which would be like this. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. Substitution prop of equality has an equal sign. Since they're both equal to 180, I'm going to set them equal to each other. Okay, now let's go back and review where we're going. I want 1 plus 2 equal to 4. Well, here's 1 and 2 and here's 4. Notice on either side there's a measure of angle 3. I ran out of room here, but let's just write this off to the side just so we could see kind of what it would look like if we had enough room. It looks a little bit more like an equation. Okay, so if I want to get rid of those, I can just subtract that from both sides because this is actually the same angle measurement. So the subtraction property of equality says I can, subtract those out. So step 4 is the substitution property. Step 5, when I subtract out measure of angle 3, I get measure of angle 1 plus measure of angle 2 equals the measure of angle 4. And that's the subtraction property of equality. All right, so pretty short proof. It's just like, 5 steps or so. If you were going to really, get into the nitty-gritty of it, you could break this into 3 steps, and it could be a little bit longer, but I think that's probably enough detail there. All right, so that's the exterior angle theorem. The sum of the 2 remote interiors is equal to the exterior. So let's go down and see how we can apply that, right? So apply this theorem that we just proved. Well, here's your exterior, and here's 2 remote interior angles. Sorry, I'm trying to think of what a symbol to label those. So the sum of these 2, it should be equal to this 2, according to that theorem. So my setup here is 7x plus 1 plus 66 is equal to 20x plus 2. You don't really need to use 180 in here. We can just go straight to this plus this equals this because we just proved it up above. Now, we're trying to find the measure of angle JAB. This is our final answer, this guy right here. Okay, not this guy, not this guy, not this guy, but JAB, excuse me. This guy right here is what we're trying to find, JAB. So once we solve this equation for x, we're going to plug that back in, and we're going to find the measure that they're looking for. Okay, so use that theorem, set up your equation, solve for x, and then look back at what they wanted you to find and find the measure of that missing angle. Okay, so that's pretty much it. 2 new theorems and their proofs, and then just using those theorems to solve problems. Okay, that should help you get started and help you with those proofs, which is probably the tricky part. And if you watched me do those and you couldn't do them on your own, what I would do at this point is go back and try to prove them on your own now. Get a separate sheet of paper, blank sheet of paper, and just see if you can write out a proof of this theorem without looking. If you need to peek, go ahead and do it, see if you can get the rest of the way there, and keep doing that until you know this proof and you understand where it's coming from. Okay, same thing for this one. If you didn't know how to get there right at the beginning, that's okay. Look at the reasoning, follow the reasoning, set up another proof on a different sheet of paper, and then practice proving it. So you understand where the proof comes from, you practice that logic and deductive reasoning, and you kind of memorize that theorem so that you can use it to solve problems. Thanks for watching.